cards. 5 cards are to be drawn. 5 cards are to be drawn. Drawn means to choose. Find the total number of ways if 1. We will see different kind of questionnaires from this. 3 cards are red and 2 are black. So before writing the second question, first we will solve the first question. So here actually from the given first line, out of the pack of cards, 5 cards are to be drawn. It is very simple because we know that a pack contains 52 cards, and from 52 cards we can 5 cards draw. We can draw 5 cards in a 52 P5 ways. But this is not sufficient because we are given the conditions have been put in the question. That means among the 5 cards, among the drawn 5 cards, the 3 cards must be red and the other 2 cards must be black. So, in the solution process, we should write that the first, among the 5 cards, the first one shows that 3 cards are red. And we know that a pack of cards contains 26 red cards. And likewise 26 black cards. So, we can select 3 cards among the 26 and the 2 cards same among the 26 because the number of red cards and black cards is same in both the cases. So, you must write here that the pack contains 26 red and 26 black cards. So, therefore the number of ways equal to 26. Actually, here one more thing. In this case, we will have to consider a different case because here is not a case of arrangement. It is not the case of arrangement. It is only the case of selection. So, one thing I would like to draw your attention here that during the question, you attempt the question, you must read the question very, very careful. And that's why I have written this question, because we want to see here our target was to discuss about permutation and combination. In permutation, as I told you, both things require selection then the arrangement. And you can see in this question that it is not the question of arrangement, only the question of selection. That means 5 cards are to be drawn. In which order? This is no important. That means the 3 cards which are red, that means which kind of card we select, this is not important. That means red card of 10, red card of jack, red card of queen or red card of king, whatever we may choose. Arrangement is not required. The order of selection is not important. See, arrangement we can also understand in another way. That means the order of selection. Order of selection. So here we need to understand about combinatorics. Combinatorics involves both permutations and combination. So here after permutation we will see about combinations. Combinations means from the given n objects, the selection of r objects is known as combination. See here, it is clearly written the word selection. There is no need of arrangement. And this we can do by using combination. And combination is denoted by NCR. NCR, or in another symbol C into bracket N comma R. And this is defined as N factorial upon R factorial into N minus R factorial. Now just we will verify this with NPR. Just we have defined as N factorial upon N minus R factorial. So this was including both selection as well as arrangement. So here, what is the difference between these two? Here we don't require the arrangement. This part includes arrangement as well as selection. But arrangement we need to exclude from this. And we know that R objects can be arranged in R factorial ways. R objects can be arranged in R factorial ways. So here arrangement is excluded, and that's why the total number we will divide by R factorial. So arrangement, we are not considering here the arrangement. So this is known as NCR equal to N factorial upon R factorial into N minus R factorial. So now let us see this example. Now I think you have cleared with the two words permutation and combination. So here out of 52 cards, 26 cards are of red and 26 cards are of black. Therefore the number of ways equal to 26C3, only selection, 3 red cards. Likewise, we at the same time we are also selecting 2 black cards. So the total number of ways is 26C3 into 26C2, and it is sufficient to write down this over here. Else, if you want to solve this, you can do this one by using N factorial upon R factorial into N minus R factorial. By using this definition, it is 26 factorial divided by I factorial means 3 factorial, and 26 minus 3 means 23 factorial. This is written as 26 factorial divided by 2 factorial into 23 factorial, and this can be written as 23 factorial into 24, 25, 26. So as we can cancel out 23 factorial. This can also be written as 24 factorial into 25 into 26. So this is the case of combination. So once again remember that don't forget here to understand the question whether it is of question or simply of selection. Now let us see another, here we also want to consider a second question. This I will give you as a homework. That means 2 cards are of heart. 2 cards are of heart, and 3 are from the suit other than heart. Actually we know that there are 26 cards are of red and 26 cards are black, but 13 cards are of heart, 13 cards are of club, 13 cards are of spade, and 13 cards are of diamond. You must be knowing, in Gujarati we are saying this as lalnu pattu, falinu pattu, kadinu pattu, chokapnu pattu. So this can be done. 2 cards are of heart. That means before solving this, you must write that there are 13 cards are of heart, and the remaining, because the 3 other one we want to select the other one. That means the remaining number of cards will be 52 minus 13. That means how much is there? 52 minus 13 is Yes, how much are there? That is total 39. But now let us see what is to do now. First we understand. Therefore, the total number of ways equal to 30C2. That means 2 cards are of heart, and 3 are from the suit other than heart. Other than heart means actually it says that 1 card from each other suits. That means 1 card from club, 1 card from spade, and 1 card from diamond. That means we can select 1 card of club from 13, 1 card from spade, and 1 card from diamond. So 13C2 is 13 into 12 divided by 2 factorial. This is 13C1 means 13, 13, 13, and you can solve this very easily. 2 factorial is 2. One more thing here I would like to say here that suppose we want to solve 8C3. You can also write down directly as 8, 7 into 6 3 times. 8C3 means you reduce 1 each time and multiply them. 8, 7 into 6 divided by 3 factorial. If you want to find out 15C12, then this can be written as 15 into 14 into 12 times. You can go for 12 times and divided by 12 factorial. But this is the 15C2 is very lengthy process because we require to write down the numbers 12 times, and it requires more time for the calculation. Instead of this, you remember here that NCR is also equal to NCN minus R. So by using this, we can write down this same thing as 15C3. 15 minus 12 is 3. And then 15C3 is very easy to solve. That means 15 into 14 into 13 divided by 3 factorial. 3 factorial means 6. We can also both have the same answer. So whenever if you want to find out this thing, then you can reduce this into the smaller one. So as you can calculate this very easily. And here actually I wanted to give this part, second part, as a homework, but I have solved this question, so I will give you another part, that means third part, that you can solve at your home. There are 2 kings, there are 2 queens and 3 kings. Certainly, as a hint, I am telling you that the pack of cards contains 4 queens and 4 kings. So this is also very simple. Fourth part, this is also for these 2 are for your homework. There are 2 aces. There are 2 aces. Aces means in Gujarati ekko. There are 4 aces in the pack of cards. So here there are 2 aces only asked, but we want to find out 5 cards. That means 2 cards must be aces. That means we can select this from 4 cards, and the remaining 3 can be of any type. Can be of any type means by deducting the number of aces from 52. That means we will have remaining 48 cards, and among 48 cards we will have to select 3. That means this we can do it in 48C3 ways. So this question is also very simple, and you can do both as a part of homework or as a part of the remaining time of the lecture. You can solve this one. Now, I will give you one more example for your practice, and that you will have to solve now or whenever you get the time. So there are 8 boys and 12 girls. And 12 girls. A committee consisting of A committee consisting of 3 boys and 4 girls. 4 girls is to be formed. Full stop. In how many ways it is possible, so that in how many ways it is possible, so that one, a particular boy is in committee. Second, this is the first question, this is the second question. So answers will be different for each type. 2 particular girls are not in the committee. And the third type, anybody can be included in the committee. So here you can see that the format of the question is very lengthy, but the solution is a very smaller part, because it is very simple. You require to understand the concept given in the question, and whatever given in the question you must write down in the beginning of the solution. That means you start with the solution. Whenever you start with the solution, then first of all you note down all those things whichever you are given in the question, because this is the very important part for your examination and for all your question. Because 1 mark, at least 1 mark you can get surely from the question itself. But you should try to you should try to know what is to write and what is given. So whatever is given, then not you write down in the same way. You write down in your own way, so that it expresses the solution procedure. So here, first of all, you should this is the question for your practice, but just I am giving you some hint. You should write first that given that 8 boys and 12 girls. In the second line, you should write that we want to form the committee consisting of 3 boys and 4 girls. That means total 7 persons should be there in the committee, and among the 7 persons, 3 should be boys and 4 should be girls. This is the second line. Then first part you should write down. First part puts some weightage on the selection of the committee. The weightage means that a particular boy must be in the committee. That means the 3 boys we want to select, and this can be done out of 3. Out of 8 boys we want to select 3 boys, but one particular boy must be there in the committee. That means, for example, suppose Mahesh must be included in the committee. So out of 3 boys, 1 boy is fixed. It is already selected without any effort, without anything. So we require only to select 2 boys. And these 2 boys can be selected out of remaining 7 boys. So this we can do in 7C2 ways. 2 boys can be selected in 7C2 ways because 1 boy is fixed there. So no need to count this into the selection procedure. And the remaining 4 girls can be selected out of 12. Then this can be done in 12C4. So your answer will be 7C2 into 12C4. you can put this, you can put or you can write this solution in a systematic way. That means by giving systematic sentences, by giving systematic words, then you will get exact mark, and also you will get 1 mark in addition to each step. In the second case, two particular girls are not in the committee. That means there are total 12 girls, from which 2 girls must not be included in the committee. This question says. That means suppose Neha and Seema. To these two girls no need to involve in the committee. So no need to involve in the committee. That means we have only 10 girls, and out of the 10 girls we require to select 4 girls, and this can be done in 10C4 ways, and other 3 boys can be selected in 8C3 ways. So 8C3 into 10C4 will be your answer. Anybody can be included in the committee. This is the general case. There is no criteria put on this. So we can select 3 boys from 8 and 4 girls from 12. That means 8C3 into 12C4. This is your answer. So boys and girls, you must have understood the concept of counting, which we have seen now, because this is the basic requirement to go for probability. So in this topic, we have gone through what is a random experiment, what is a sample space, what is a trial, what is an event, then what is an outcome, and then we have seen different kinds of events. That means equally likely events, mutually exclusive events, exhaustive events, compound events, independent events, dependent events. So, and also I told you that from this mutually exclusive events, dependent event, independent event and compound events are of very much important. Then as a pre-requirement, we understood the concepts of counting, in which we have seen first fundamental theorem of counting. This is m into n. Then we have seen permutation and combination. Once again repeating, permutation is the number of arrangements, that means after selecting some number of objects and then to arrange them. And combination is simply the number of selection, it excludes the number of arrangements. So students, you must have understood this topic, and you can study these examples and these concepts for the next lecture, next session. In the next time, we will see